Hi there, and welcome to this lesson. In this lesson, we're learning differential calculus, okay? And under differential calculus, we'll be learning about the derivative of a sum. Okay, very interesting. Now, at this point, I'd remind you to set the video to play in 1080p HD. Very important that you do so. And as the lesson progresses, if you have any issues at all, anything comes up as unclear, please feel free to get in touch. Okay, we would be very happy to help, and you can do so via the course dashboard. Okay, let's jump right into the lesson. So differential calculus, the derivative of a sum. Now the derivative of a sum. Now how do we go about finding the derivative of a sum, and what is the derivative of a sum for exactly, basically? Now the derivative of a function that is a sum, okay, of smaller function is the sum of the derivatives of the individual constant functions. Okay, let's understand this. Okay, what is this exactly? Now if you consider the function y equals x cubed plus 5x squared. Okay, so basically this is a sum, so x cubed plus 5x squared of two smaller individual functions, and you want to find the derivative of this function, you'd simply say that dy dx is, do you find the derivative of the first function, x cubed, so you have 3x squared, okay, plus the derivative of the second function would be 10x. So what we have in the end is we have 3x squared plus 10x, and that is it. It's that simple. And there's certain things you need to take note of. If you have y equals x, the y dx equals 1. So if you're ever given a function when you have an x in there, you need to know that the y dx, when you find the derivative of x, you have 1. Okay, and if you have a situation where you have a constant, okay, so a constant like 2, 3, 5, 7, 20, 95, any number at all without a variable there, you would have the y dx as 0. The derivative of a constant is 0. And that's pretty much all we need to know. I think we can go ahead and solve some examples now. So example 1. And example 1 says if y equals x cubed plus 6x squared minus 4x plus 3, find the y dx. Okay, so we have the y equals x cubed plus 6x squared minus 4x plus 3. Okay, we've been asked to find the y dx, and all we have to do is we have to differentiate the individual functions there. So we'll start with x cubed, and what we have is 3x squared. Okay, and then we have plus 6x squared. I think if you derive that, you'd have plus 12x. Okay, and then you have minus 4x, you derive that, you have 4. Okay, so minus 4, and then you have plus 3 at the end, you derive a constant and find the derivative of constant, and you'd have 0. Okay, so you have 0 in the end there. Okay, and I think you can break that down. You just take out the 0, you have the y dx equals 3x squared minus 12x minus 4. It's that simple, really. There really isn't much to it. Let's do another example. So example 2, and example 2 says if y equals 2x cubed minus 4x squared plus 7x over x squared, find the y dx. Okay, this looks a bit but it's actually quite easy. So the first thing we want to do, we have that y equals 2x cubed minus 4x squared plus 7x over x squared. Okay, I want to simplify this. Okay, so I divide all through by x squared, and what I have is I have 2x minus 4 plus 7 over x. Okay, so now you have a sum. Okay, you've taken out the quotient there, and you can then go ahead and say y equals 2x minus 4 plus 7x to the power of minus 1. So I don't want that fraction there. Okay, I want it written as 7x to the power of minus 1, so it can make differentiating that a lot easier. So and then step 2, and for step 2 I'd say y equals 2x minus 4 plus 7x to the power of minus 1. I'm going to find the y dx. The y dx of 2x is 2. Okay, the y dx of minus 4 is 0. Okay, so we can just take that out, and then when we differentiate 7x to the power of minus 1, we have minus 7x to the power of minus 2. Okay, so we have 2 minus 7x to the power of minus 2, and then we have finally the y dx. I'm just going to write 7x to the power of minus 2 in simpler form, so I have 2 minus 7 over x squared, and that is the y dx. Very simple. Let's do another one. Example 3. And example 3 says if y equals 3 root x, find 5 over root minus 5 over root x, find the y dx. Now, how do we go about doing this? So the first thing we want to do here we have y equals 3 root x minus 5 over root x. What we'd have is we'd have y equals 3 x to the power of 1 over 2 minus 5 x to the power of minus 1 over 2. Okay, so we have 5 over root x, 5 divided by root x. What that gives us is 5x to the power of minus 1 over 2. Okay, and then the next thing we want to do here, we have 5y equals 3x to the power of 1 over 2 minus 5x to the power of minus 1 over 2. To find the y dx, we have we differentiate 3x to the power of 1 over 2. We would have 3 over 2 x to the power of minus 1 over 2. Okay, basically we have 1 over 2 multiplying 3, giving us 3 over 2 x to the power of 1 over 2 minus 1. That's minus 1 over 2. Okay, and then we have minus, and we're going to differentiate 5x to the power of minus 1 over 2, and what we'll have is, I think, minus 5 over 2 x to the power of minus 3 over 2. Okay, so we simply have minus 1 over 2 multiplying 5 gives us minus 5 over 2, and then we have x to the power of minus 1 over 2 minus 1, that's minus 3 over 2. Okay, and then we can say the y dx equals 3 over 2 root x. Okay, so we have x to the power of minus 1 over 2 in this case, so we have 3 over 2x, and I think minus minus becomes plus, plus 5 over 2x root x. X to the power of minus 3 over 2 would be 5, basically would have 5 over x to the power of 3 over 2, and basically we have x to the power of 3 over 2 is x to the power of 1 multiplying x to the power of 1 over 2, if you follow, and then you'd have that x to the power of minus 3 over 2 is x 1 over x root x. So what we have in the end is we have 5 over 2x root x, and that is how you find the derivative of a sum. Actually very easy. All you need to take note of is to find derivative of sum, you simply find the derivative of the individual functions of the sum, and you pretty